Okay, so this is where we left off in lecture, finding the concentration of either OH or H plus, depending on what we're given, right? So every solution has a little bit of OH, has a little bit of H plus, but what determines if it's acidic or not is if you have, acidic or basic, depends on if you have more or less of the other. So in this case that we looked at in the last example, we had more H plus, which made the solution acidic, okay? And with negative exponents, the smaller the exponent, the more you have, okay? So how does this relate to pH? That's where we're going to start for our little pre-lab lecture, okay? So pH you might be familiar with. It's a scale used to determine how acidic or basic a solution is. So we're going to relate this to what we just learned here in a second. So the pH scale, this is a pretty little picture, but it's not perfect. The pH scale is 0 to 14, with 7 being neutral, okay? So anything that's 0 to like 6.99 is acidic, 7 neutral, 7.01 to 14 is basic, or also called alkaline. Okay. So, like I said, this is a good representation, but it's not perfect. It labels blood at 8, which blood is actually 7.4. But you get the idea, right? So coffee is acidic, lemon juice is acidic, vinegar, right? We have our extremes, stomach acid, uh, battery acid, and then soap and stomach tablets. So this would be anything you do like antacids, baking soda. These are all basic, and your extremes, bleach and drain cleaner. All right. So how does this relate to the concept we just learned of H plus and OH minus? Okay. So there's a formula. pH equals the negative log of H plus. Okay, so it's important that we know how to use our calculators and how to type this in. Okay, so for you it's going to be one video, but I'm going to make this in two parts myself. Right now I have a screen recording. The next part I'm going to videotape myself with a calculator so you can see how to type this in on the calculator that I recommend. Unfortunately, I don't have like the other calculators, but hopefully it gives you an idea. Okay. So I have another slide about this in a little bit, but H plus and H3O plus mean the same thing. So if you saw the formula pH equals negative log H3O plus, it's the same formula. So you're just entering the concentration of acid in the solution here to find the pH. Okay. So pH has to be a number 0 to 14, and it's never negative. Okay. If you get something that's not 0 to 14, or if you get something that's negative, probably didn't type it into the calculator correctly. All right, so here's a little practice problem. So we want to calculate the pH of a solution that contains this amount of H plus. Okay, so our formula, pH equals the negative log of 1.4 times 10 to the negative 3. pH equals. So once you type this into your calculator, again, in my next part, I'll do this on a calculator. Here, I'm just going to give you the answer and hopefully you can check it. So the answer is 2.85. Okay. So some things to note, how to know we're on the right track. So these kind of have ways of checking ourselves. So 1 can't be negative, 2 has to be 0 to 14. And then the third thing I look for, and this helps me actually grade your guys' labs really fast, is I'm looking for a number that is near the exponent number, all right? Maybe it's a little bit above, maybe it's a little bit lower, but if you have 12 something and your exponent is negative 3, that's a red flag, all right? The exponent kind of helps drive what the pH is, okay? All right, so that brings us to this question about what if you're given OH and asked to find the pH, okay? Because we knew how to connect OH and pH. yeah, OH and H plus. This is the KW formula. And we just learned how to connect these two, okay? But what if you're only given OH and you want to find pH? So you'd have to do two steps. You'd have to do the KW formula and then the negative log of H plus formula, okay? But as you see in this image, there's a lot more formulas, okay? So I think it's kind of beautiful, this acid-base square, where we can connect all four of these ideas. I'm about to say what POH is here in a second. We can connect all four of these ideas with different formulas. And in fact, if we're trying to go from here to here, we have this way, or we have a different way, okay? So this will be given to you on a reference sheet. If you are doing the lab at home, might be great to Google one of these, have this up while you're doing the lab, or print out the slide or whatever. So, so we talked about this formula. We talked about this formula. So this, let me use the laser instead. This is the inverse of a log, okay? So 10 to the negative pH is how we would go from pH to H plus. Okay. There's also this concept of POH. Okay, and this is my next slide. POH is the inverse or the opposite of pH. So you can actually find POH value doing that same formula, negative log to OH, right? That's going to give you a POH value. Okay. POH and pH are the opposite. And so they have to equal 14. Okay. So POH plus pH equals 14. Okay. So looking back at this acid-base square, if I was given OH and asked to find pH, I personally, and this is what I recommend to y'all too, I personally like to take the route that includes POH plus pH equals 14 because it's way simpler than the opposite over here with all the exponents and all that gnarly stuff. pH plus POH equals 14. It's kind of hard to mess that one up. This one, very easy to mess up, especially when you type in the calculator. But yeah, POH is the inverse of pH. So if you have a high pH, say it's like 8, then you should have a low POH. 4. No, they have to add up to 14. Duh, Kayla. 16. All right. So I have 2 practice problems on the next one. All right, so what is the POH of a solution that has 5.4 times 10 to the negative 5? I should put molar on here because that's technically the unit. All right, so this, if I go back to my pH square, we're going from OH to just POH. So we would use this formula. POH equals the negative log of OH. So POH equals negative log of this guy. All right. And for that, I got 4.26. All right. Now, if I wanted to determine if this solution was acidic or basic, I could put it on the pH scale. So I could just take this value, 14 minus 4.26. I don't have my calculator in front of me. Let's see here, 14, 9 something, 9.74. Yeah. All right, that would be the pH. And then I can, put that on the pH scale. So it's 0 to 6.99 is acidic, 7.01 above is basic. So the solution would be basic. All right. All right, here is a 2-stepper. We're given H plus and we want to find the POH. So I'm going to go back to the acid-base square. Let's clean this off a little bit. Okay, so we're given this and we want to find this. So like I said, we have 2 routes, but I always personally like this route where I use this formula, the pH plus pOH over the opposite formula, just a lot less messy. So my first step, I will find the pH using the negative log formula, and then I will subtract that value from 14 to get the pOH. Okay, so pH equals the negative log of 7.3 times 10 to the negative 10th. Oh, another way to check ourselves on the last problem, right? Our exponent was negative 5. We got 4.2526, right? That's good. Right? Okay, so here now I'm looking for a number. Might be 11, might be 9, might be 10, but I'm looking for something between 9 and 10. That's when I know I've typed it into my calculator correctly. And when you do this, you get 9.14. All right, so that's my pH, but I'm trying to find pOH. So I can do pOH plus pH equals 14. So I have 9.14 plus x equals 14. I can subtract that from both sides. X equals... Did I not write down the final answer? Of course I didn't. 14 minus 9.14. 4.86. All right, so this is my pOH. Okay. So that would be my final answer. But if they ask me if the solution is acidic or basic, I would be looking at the pH here, putting that on the scale. So again, it's in the 9, so that's basic. Okay. All right, we have another practice slide. I will let you do this practice on your own. I'll just tell you the answers here. So you're supposed to rank them based off their acidity. So like most acidic to least acidic. So you're looking for something that's like 0 to like 7 here. Maybe even, it might, actually, I think these do go up in the 14s. All right, so the correct answer, this is the most, this is this intermediate, and this is the most basic. If you want to check yourself, you know, pause and do that. We'll skip this slide. Okay, we do need to talk about this slide. So buffers. So your discussion post this week asks for what is a buffer. So a buffer is a weak acid solution that can resist major changes in pH. Okay, so if we look at this image, here we just have water. It's at a pH of 7. Let's zoom in on this. pH of 7. All right, when you add HCl, which is an acid, a very strong acid, by the way, it goes down to 3. Okay, but when we have a buffer and we add this very strong acid, it does go down, but just to 6.9. Okay, same thing over here with bases. So buffers resist major change in pH. Yeah, the pH is going to change, but they resist the major changes. And blood buffers are very important in our body, right? This is why we can drink coffee, which was a pH of, let's see, 5, and not die, right? Because our pH, our body's pH, has to stay between 7.35 and 7.4 in order for us to be healthy, happy. But we can, you know, we can eat that lemon juice, we can have the vinegar, and what our body does is it resists the major changes using a buffer. Okay, that's all we need to know. It's really cool stuff, actually, your blood buffering system. But that's all you need to know for our level of chemistry. So there's buffering systems in the blood, but there's also urinary, a urinary system, so where you can excrete all the extra you know, hydrogen ions you don't need. You can also, there's a respiratory version. So you breathe out CO2, take in oxygen, your breathing level will change. And there's also a blood pressure one, I believe. I learned about them all in undergrad, but that was quite a time ago. But it's very cool. We have a lot of different systems in place to keep ourselves in that normal pH range. Okay. All right, one last slide, has kind of nothing to do with nothing. But we just need to know the definition of these two words. So oxidation is a reaction that is losing electrons. And then reduction is a reaction that is gaining electrons. Take note here that the definitions are kind of opposite of what they sound like. And it has to do with the charges. I get myself confused when I try to explain this, but all y'all need to know is the definition, and it will be just fine. You just have like one question that says, is oxidation gaining or losing? Something like that. Or reduction. I can't remember which one it asks, but as long as you know the definition, you should be fine. Okay, so this could be one video for y'all, but I'm gonna stop here, get myself set up for more of a camera view so you can see my calculator.
Okay, this setup is not perfect. I cannot figure out wave where you cannot see the box that I'm propped up on, but we're gonna go ahead and go forward because you should be able to see the paper and then the calculator. All right, so in this lab, we would have tested the pH of different household items. So we would have had a few pre-lab questions and we're going to go over these right now. So the pH, the equation for pH, all right, so pH equals the negative log of the H plus concentration, okay? The equation for H3O plus, H plus, so this is the inverse of this last equation. It was on our acid-base square, but we'll just write it out here. So H plus equals 10 to the negative pH. So that negative pH is in the exponent. The equilibrium constant, the KW formula, that is 1.0 times 10 to the negative 14 equals OH times H plus. Okay. And then what does it mean to be acidic or basic? So 0 to 6.99 acidic, 7 neutral, 8 why am I blanking? 7.01 to 14 basic. All right, so pause now to add these to your paper. All right, so then the next page is actually taking the data, okay? So unfortunately, we're not in lab, so we can't take this data. So what you're gonna do is you're just gonna copy these values. I took this from a student on Tuesday's lab. I just took the values they got. So we ended up testing tap water, a low concentration of HCl, vinegar, milk of magnesia, which has a few different purposes, but it's basic. It likes to quench stomach acid, Coke, coffee, bleach, baking soda, alcohol. Not the alcohol you're probably thinking, it was NaOH. And then we also did alkaline water. So you don't have to make predictions, but I do want to point out that the alkaline water, because you know how alkaline water is the whole trend and all this stuff. So the alkaline water on the bottle claimed that it was 9.5, but it's just normal water. I think that's interesting to point out. Okay, so you're responsible for filling in these two. I'm gonna do a couple, I would say let's do two together, but then you're responsible for filling out the rest of this, okay? So, how to go from pH to H plus, okay? So that's gonna be this formula right here. We want H plus, we have pH, okay? So pH plus equals 10 to the negative pH, okay? So 7, so here's my calculator. So I would do 10, caret key, or however you do the exponents, negative 7. All right, so my calculator is already in scientific notation. And how you read this is, let me try to get it here. So this reads as 1.0 times 10 to the negative 7. Don't forget this tiny times 10 down here. All right? So 1.0 times 10 to the negative 7. Okay? Now, if your calculator was not in scientific mode and it came up as something like this, oops, that's if it had 6 zeros, that's the correct answer. But how we get to that mode, first let me get off camera and change it back. Okay, so let's say I typed it in and I got 10 to the negative 7. I got this, okay? Technically the correct answer, just not in scientific notation. And it's just easier to put in scientific notation. So for these calculators, you do second, this button to the right of it. Flow is like normal. And then you hit psi, you scroll over, hit psi, enter, and that will bring us into that scientific notation. Okay, so it's good to know how to go back and forth, because sometimes then on the next page, we're gonna get, it's gonna try to put pH in scientific notation, and then that's gonna look weird. So it's good to know how to go back and forth. But right now for this table, I would say you want your calculator in scientific notation. Okay, so let's do this one next. Okay, so clear 10 to the negative, oh, that's pi, negative 1, or the negative pH, I get 1.0 times 10 to the negative 1. All right, so then you pause, fill in the rest here, okay? How to get this next column. So we want to go from H plus to OH, okay? So back on the front page, that was this formula, all right? So let's talk about that. Okay, so we have the H plus. All right, so at the bottom here, I'm going to show us the math. All right, so we have 1.0 times 10 to the negative 14th equals H plus times OH minus. So we have this value, all right? We have 1.0 times 10 to the negative 14. I'm going to do the first one here. We have 1.0 times 10 to the negative 7. All right, now we can substitute this value as x and divide each side. All right, so we're dividing this 10 to the 14th number by whatever we found here. Okay, I forgot to put a negative sign. All right, putting this into our calculator, we have to use parentheses, or else it's going to be a hot mess. You're going to get the wrong answer. So open parentheses, 1.0 times 10 to the negative. If your calculator has a negative button, use that over the minus sign. Sometimes if you use the minus sign, it'll give you an error. So it's negative 14, close parentheses, divided by, open the parentheses again, okay? This is where I saw a lot of errors on Wednesday's lab. So open parenthesis, 1.0 times 10 to the negative 7, close parentheses. All right. 1.0 times 10 to the negative 7. This is the correct answer. Although it looks the same, I will tell you it is correct, and I'll explain that in a second. Okay, so let's do the next one. So now, instead of dividing by 10 to the negative 7th, I'm going to divide by 10 to the negative 1. So open parentheses, 1.0 times 10 to the negative 14, close, divided by, open, 1.0 times 10 to the negative 1. All right, we get 1.0 times 10 to the negative 13. All right, So a way to check yourself. The exponents here should add up to 14. Okay, so 7 and 7 add up to 14. 1 and 13 add up to 14. And you should see that continue as you go down. All right, so pause now, finish this page. All right, the back page, the post-lab questions. These are a little bit trickier. We're gonna do, let's do like the first 3 together. So you might want to, we might be switching the calculator back and forth. In fact, let me give you some pointers here. If we're looking for the answer to be H plus or OH minus, we're going to want to be in scientific notation. If we're looking for the answer to be a pH or a POH value, that's when we're going to want the normal. In the calculators that I'm using, it's called flow. No clue why, but that's what it is. All right. Also important, we have to determine if each solution is acidic or basic. Okay, so you're answering the question and then determining if it's acidic or basic. All right, so if you are good at seeing patterns, you would have noticed that this column ends up being the exponent here. Okay, but all of these were whole number pHs. Okay, that trick only works when your pH is a whole number. Okay, here we have pHs that are not whole numbers, so we gotta do the math. Okay, so like I said, hopefully you have an acid-base square in front of you, or you have it referenced like somewhere, but yeah, that'll be helpful. So find the pH. So we want to know the pH of a solution that contains an H plus of an and we're given that concentration. Okay, so here we would use the negative log formula. Okay, so pH equals the negative log of this value. All right, so now since I'm finding a pH, I'm gonna change my calculator back or else it's gonna look funny. Okay, so negative log, where's log on this one? Log. And then it already opens a parenthesis for me, which is great because this number, I want to make sure that all of that ends up after the log. So 4.49 times 10 to the negative 11. All right. I'm going to round just 2 digits after the decimal here. So 10.35. That's my pH. Okay. All right, so if I want to determine if this is acidic or basic, I can do that because the pH, I can just, 0 to 6.99 is acidic. This is above that, so this is going to be basic. All right, so questions that are similar to number 1 here. So number 4 is going to be the same setup as number 1. Same as number 7. All right, so those use that formula. Number 2, find the H plus of a solution that contains a pH of 12.5. So now we're doing the inverse of this equation, and that's that H plus equals 10 to the negative pH. All right, so 10 to the negative 12.25. All right. And I'm going to change my calculator back to scientific here. Okay, so 10 to the negative 12.26. All right, so here's my answer. So it is totally okay to round this. So I think I'm going to round to 5.50. But on my paper, I need to make sure I still write times 10 to the negative 13th because that's still part of the number. Okay? So 5.50 times 10 to the negative 13. Okay. This pH is in 12, so that's greater than 7. So this solution is basic as well. Okay. So number 5 is the same as number 2 here. Same with number 8. Okay. Here, find the OH of a solution that contains a H plus concentration of this. All right, so here we're using that KW formula where 1.0 times 10 to the negative 14th equals H plus times OH minus. So I'm going to plug in my H plus. All right, and then divide each side by this so that we can get OH by itself. Okay, so let's see here. Open parentheses 1.0 times 10 to the negative 14, close parentheses, divided by, open parentheses 4.49 times 10 to the negative 11. All right, so same thing. I can round to the first 2 digits after the decimal here, but I need to make sure I write down this because that's part of the number. So I'm going to say 2.23 times 10 to the negative 4. All right. Now I need to figure out if it's acidic or basic. This one is a little less straightforward, okay? So you want to look at the exponent on your H plus value, okay? Sometimes your H plus will be the one you solve for, or it might be the in the problem. This one is in the problem, okay? That exponent, you can put that exponent on the same scale here, where 0 to 7 is acidic, greater than 7 is basic. So this exponent is 11, so this solution is basic. All right, there's a few other ways of doing it, but I think that's the most straightforward, okay? So similar to number 3 here is going to be number 6 and then number 9, all right? So the rest, do on your own, and that is it. So turn it into me. You know what, I'm not going to say that in the video because I'm still figuring out the logistics of that.